Assalamualaikum and good morning, class. Today topics will be on composite material and bonding. First of all, what is composite material? By definition, it is a microscopic mixture of two or more different materials, one typically being the continuous phase, which is what we call it the matrix, and the other being the discontinuous phase, which is the reinforcement. It is its properties are strongly dependent on the composite structure, ductility of matrix combined with the stiffness of the reinforcement. So, examples of matrix is resin, the types of resin that we use, and examples of reinforcement or the discontinuous phase is the fibers. Example, we have composite fiberglass fibers, carbon graphite fibers, and etc. So, in aircraft construction, aircraft construction, most of our new generation aircraft is using the composite material because due to its strength to weight ratio, and we can customize the strength of a certain load that requires for the aircraft structure. So here, if you look at this diagram, uh, for the latest A350 aircraft from Airbus, okay, more than 50% comprises of composite material. Okay, example, here we have another picture of the A380. If you look here, the tail section, the tail cone, okay, the pressurized bulkhead, and the wing ribs, okay, are all made from the composite material due to its lightness compared to metal structure and its strength. Okay. And also for Boeing 787, the new generation of aircraft, the Dreamliner, is also having more than 50% of composite parts is made from composite material. So this trend will increase, okay, year by year for the new aircraft generation because nowadays, due to the high prices of fuel, right? So we want to use. It's better for us to have a lighter aircraft which can increase our payload. Okay? Payload for airlines means money. Okay? The higher the payload, the more money they can generate. This is also another aircraft that been using carbon composite material structures. Okay, so if you look here, uh, we it comprises of carbon epoxy composite material. Epoxy is the type of matrix or the resin. Carbon is the reinforcement. We also have the combination of carbon, aramid, epoxy, glass fiber, reinforced plastic, aramid. Aramid, other name for aramid is Kevlar. Okay, uh, and all other types of composite material. Okay, the latest methods of constructing the fuselage of the aircraft is also by using one of the composite material process or technique, or we call it tape laying. Basically, you have a mold, and then you lay like a tape, yeah? And the tape is actually normally they will using the pre-impregnated materials, which the fibers is already comes with the resin. Okay, so you just do like a tape laying based on the mold. Okay, and then you cure the composite material. Okay, here we have the schematic diagram of the fiber reinforced composite material. The fiber reinforced polymer consists of two components, the polymer matrix and the reinforced face. They are produced separately before being combined to make the composite part. We know that how does we gain strength from the composite material is actually by having the combination of the two material, which is combination of matrix and also the combination of reinforced face or the fibers. Okay? So if we have separate matrix or separate fibers or the reinforcement, you do not have the strength. Okay, so you need to have these two to combine together in order for you to achieve the strength that you require. Okay, so basically, if you combine these two, it becomes a synergy, okay, where you gain the strength. If you have the metric by itself, when you cure the matrix, only the matrix, it becomes brittle. Okay, and if you have only the reinforced face or the fibers, it's just like our shirt or a textile. There's no strength on it. Okay, and except when you combine these two components together, then you can produce a strength of composite parts. And then for matrix, we have several types of matrix here that normally use. We have thermoplastic, thermosets, and elastomers types of polymer matrix. And then thermosetting polymers are the most common matrix material. Example is epoxy type. Okay. So here there is a note stated that the strength will be on the grain direction, length, side, angle of the fiber will also determine the strength of the composite structure. So the advantage of composite structure is actually we can customize the strength based on our needs or based on the load exerted on the structure. Okay, so that is the beautiful of composite material. Unlike metal basically in every side or in every direction they have a specific strength. Yeah? Everywhere, every side of the metal is have a specific, a same strength that you cannot customize. Okay, but for composite material, the beauty of having composite material, we can customize the composite structure. Okay, Okay, types of reinforcing components or the fabric or the fibers is normally comes in three forms. We have thread, cloth type, and also mat. Okay, so loose fibers are used in some fabrication processes in a continuous form known as roving, which is a collection of untwisted continuous thread. Each thread consists of 1 to 30,000 single fibers. We also have cloth. It's a fabric type. Okay, some special cloth can consist of different fibers. For example, the combination of carbon fiber and glass fibers. So that is also another advantage, meaning that you can mix two different types of material to become one cloth. Okay, and then we also have mat. It's a material that consists of randomly oriented short fibers. Okay, and normally for aircraft application, we'll be using cloth type because we it is a structural, so the strength will be more compared to fibers and mat type. Mat type is normally we use for non-structural parts and component. Example, we can use it for to make a boat. Okay, a fiberglass boat. We can use a mat. Okay, and also in some application, raw materials are combined prior to shaping operation. The resulting material is known as pre-pack. This is what I explained previously on tape laying, meaning that the cloth itself comes with the resin, okay, mixed together with the cloth, okay, and it is a we call it a pre-preg material. A typical thickness of the pre-preg is 0.15 millimeter with a 34% of polymer resin. The pre-preg is available as a strip with width of 300, 500, 1000 millimeter and a length of 50 to 100 meters. Okay, so by having this pre-preg, we can skip the hassle of having mixing the resin and applying it on the cloth, meaning that we have we can straight away use this pre-preg material and then we can just cure it later on. Okay, class, that's it for today. Thank you very much. Assalamualaikum.